Let's officially start our lecture on control structures in processing. To begin, we're going to look at the simple if statement. So the simplest form of decision structures is a simple if statement. If statement, as I have an example down here, has two components, a condition and the block. So it's called the if block. So this is the condition of the if statement. It would either be true or false. And here, this is the block of the if statement. So this is also called the scope of the if statement. If the condition is true, you're going to execute the statements in the if block. If the conditions are false, you're going to ignore those statements and move on to the rest of the program. This is the same. This is true in real life as well. So for example, if you say, if it rains today, I'll take my umbrella. If that condition is true, so if it rains, you will take your umbrella. If it doesn't rain, you're going to ignore what you were going to do in the case that the condition was true. So if it doesn't rain, you simply don't take your umbrella. So it's exactly the same thing. Let's show this using a flowchart. So the flowchart of a simple if statement is quite simple. You would have your test condition. If the condition is true, you're going to execute the statements within your if block. There could be only one statement. There could be many statements. If it's false, you're going to basically bypass those statements and you're going to completely ignore them. Your program is going to, so your program basically will have two different paths, and the paths are going to unite after the if statement. And you move on to other steps. The flowchart, as you see, maps perfectly to an if statement. So the condition, the statements, as well as the next statements that you have to go through. So let's see an example. So if you have the setup function, we have double price 50. So just gonna draw the memory diagram here really quick. We have setup, price is 56.0000 because it is a double. And then we have the if statement. So in the if statement, we have our condition. This is the condition. And the condition must be Boolean compatible. I'll talk about this further in my slides. But basically, Boolean, it means that it either is true or false. And we'll discuss this in a minute. And so we have the condition and we have the if block. So in this case, is the condition true or not? If price is greater than 40, the price is greater than 40, so the output of this program is actually these two sentences are outputted to the screen. So in the console, you're going to have it's too expensive, buy. So go ahead and program this on your PDE and see what you get. Let's talk about comparison operators. In order for the condition of the if statement to be evaluated, we need comparison operators. So let's let me show you what I mean. When we have if, in this condition needs to be, as we said, Boolean compatible, which means this condition is actually a logical expression. So what is a logical expression? You guys are all engineers, you know what mathematical expressions are. A logical expression is an expression that evaluates to either true or false. It evaluates to either true or false, so you can have it as and you know, true is often denoted by 1, false is often denoted by 0. So if you have something like if, let's say you have int a equals 10, and if you say if a greater than 5, this is a logical expression because it evaluates to true or false. A is either greater than 5 or a is less than 5. If it's greater than, or it could be equal to 5. Here in this case, if it's greater than 5, this is true. If not, it's false. So that's the logical expression. I want to talk about Boolean a little bit here. So Boolean is basically a value that is either true or false. In processing, there is actually a Boolean variable. And we'll show an example on this a bit later. But basically, just like when you have int a 10, you could also have Boolean, and you can just call it b. And the way you initialize this is to either true or false. So true and false are actual keywords in processing. So this would be, let's say, true. So in memory, A is 10, B is true. That's basically how it looks. Or you can just, you know, later on set it to false. You can say B is false. So just like when you say, for instance, just like when you say A equal 10 plus 6, and the value of this changes and becomes 6, you could say B, and you would basically, so this is a mathematical expression. You could have a Boolean expression, so you could say B equals A greater than 5. So when I said B is false, the value of B in memory is actually false right now. Here, when I say B equals this, what is the value of this expression? A greater than 5. Is A greater than 5? Yes, it is. The value of A is actually 16 right now, 10 plus 6. So the value of B is going to be true, because when you evaluate this, this evaluates to true. So this is a logical expression. It's a logical expression. So when you want to have an if statement, when you say, if you want to have an if statement, if you say if, and this is the condition, the condition must be a logical expression. A logical expression is an expression that evaluates to either a true or a false. So if I have int a, I would have if a is greater than 200, print out, let's keep it simple, print out hello. Okay, in this case, a is greater than, if a is greater than 200, is this logical expression true or false? In this case, this is false, so nothing is going to be printed to the screen. As you have been watching, all of these logical expressions are possible using these operators, which are called comparison operators. So let's look at comparison operators and see how many we have. Basically, this is a review of what you learned in elementary school. So there are a few of them. There is less than, we have less than or equal to, greater than or equal to, we have equal to, and we have not equal to. You have to make sure that, first of all, there is no space between these symbols. That's really important. And the other thing is that you need to watch the order. So if this is less than or equal to, you can't move the sign over here. This would cause a compilation error. So more examples of compilation errors. A quick example about comparison operators. So if you have quantity less than 50, this would be true if quantity is less than 50. If quantity was equal to 50 or greater, this would be false. This statement would be true if age is greater than 25 or equal to 25. So if age is less, then this would be false. When would this be true? This would be true if on hand and target are exactly equal. This would be true if quantity is not equal to 7,500. So if quantity was also 7,500, this statement would be false. One thing that I wanted to talk to you about is that don't check for equality. So like this guy and this guy, you only want to use them for let's start from the top. You only want to use them for ints, and later on we'll show you how you can use them for chars and strings. Why is that? You basically do not want to use these for doubles or floats. The reason is doubles or floats are not precise numbers, if you recall. So let's go back to the notes. If we have int a 10 and int b 10, in memory we're going to have a, it's going to be saved precisely as 10, b precisely as 10. So if we say if a equal b, do something, this is going to be true, which is what you want, right? Because they are equal. So if you check two integers, it works because they are precise. But if you have two doubles, so if we have double x, let's say 5, double y, this is going to be saved in memory as 5.0000, maybe a 1 at the end. And then y is going to be saved as 5.000, maybe the 2 at the end, something like that. So when you try to say if x, when you try to check that, what ends up happening is, depending on your luck and depending on the system, this should return true. This should be, actually, when I say return, I mean this should evaluate to true. but a lot of times it could be true or false depending on how the numbers were stored on the system at the time, because so this is because doubles aren't safe precise. So the equal operator doesn't work for doubles or floats due to issues with precision. Let's do another example with regards to Boolean. So we said that Boolean is true. It could be true or false. True is 1, and then false is 0. So if you have int x, let's draw this, x as 7 and y 9, Boolean. Right now, Boolean holds garbage because nothing is assigned to it. Then we're going to be bx less than 7, bx less than y. Is x less than y? It happens that it is. So b is gonna become true. So what happens when you print it? When you say print, the value is b. What's going to be printed is this. The value b is true. So b contains true in memory, and actually the word true gets printed out. So go ahead and try this on processing and see the output that you get. A common error that occurs is, can we use one single equal sign instead of 2 equal sign? What do you think? Could you? The answer is a big no. Basically, if you wrote this, if you assign x to 0 and you said if x equals 5, this in processing is going to give you a compilation error. The reason is that single a is used for assignment. So this is used for assigning a value to a variable. So here in this line, what you're telling to the computer is that you make x and put assign the value 0 to x. Okay? The double equal sign, it means checking for equality. So this checks for equality. So when you have this is actually a compilation error, and you need double equal signs. So they mean completely different things, and you don't want to do that. So basically, rule of thumb, let me just get rid of this. Rule of thumb is that you want to use the equal inside the condition tests and use the single equal sign outside the condition test. So this is quite important. Let me just go back to this. Okay, so one thing that's really important is that you want to make your code readable, right? Your code works even if it's not readable, but what you need to do is you need to make sure that you write code in such a way that you could go back to it and read it easily, or your colleagues, your teachers can read your code. So the readability of code is really important. That's why we're asking you to indent your code. So what you want to do is you want to make sure that you have brackets in this way, or have them in this way so that they're sort of standardized. They help clean up your code. More of that, what I would like everybody to try to do is to try to organize your code by indenting it. What that means is you want to have different indentation level. So the first level is if you have a setup, and the void setup, that would be 1, that's level 0. For every variable you define, any other statements that you write, you want to go ahead and indent once. And also, if you have anything inside your if statement, you want to indent once more. So if your code is really messy, one trick in processing is if you go Control T, it kind of aligns things for you. So that's one trick that processing does. But this is basically what I want you to follow. It's going to make life a lot easier for you in the long run. I should mention that I've been talking about the if block. If inside of your if statement you only have one bracket, if you only have one statement inside your if statement, inside your if block, you don't need to put braces. So normally you would have braces here, but if you only have one executable line, so if you only have one line, then you can get away with not having these, and you can just sort of indent. So that's something helpful. It is recommended you put the braces in. It's going to make the program more readable, as the monkey suggests. But you could get away with not putting the braces in. Okay, I'm going to finish this video with talking about something that's really important. So we have been talking to you guys about putting a semicolon after each statement in processing. When you put a semicolon, it tells processing that this is I'm done with this statement, and you can take that as a statement. So it's kind of like a period at the end of a sentence. The if statement is an exception. So you never ever want to actually put a semicolon at the end of your if statement. What do you think it does? Do you think you'll get a compilation error if you put a semicolon at the end? No, you actually don't get a compilation error, and that's the dangerous thing. What ends up happening, the semicolon is actually known as the do nothing statement. So if you put a semicolon at the end of an if statement, what it means is you're just going to ignore your if statement. So the if statement is just going to be ignored, and whatever is inside the if is going to be executed. And it's going to drive you crazy, because even though the condition is false, you're still going the if statement. So you think that all logic has been destroyed. So make sure you never ever do this. Make sure you always have you never have a semicolon at the end of the if statement. I'll just do a quick example and show you what I mean in processing. So if I have int a as 10, and if I say if a is greater than 100, and I could just go ahead and I don't need the brackets. Actually, let's put the brackets in just to make a point. And here I would just say, let's say, print ln. Again, we'll go with hello. All right. So obviously, hello should not be printed, right? So let's run this. And the output is nothing. Hello is not printed. Now, if I come and put semicolon at the end, and now run it, hello is printed. So that this means that basically processing is completely ignoring the if statement, and it just goes inside and does whatever, because we have the do nothing statement in place. So make sure you check for this. People go hours and hours in frustration looking at their code, nothing seems to be wrong, and then they have the do nothing operator, do nothing statement in place. All right, thank you.